Oh, hi there. You really wanted to be in this video. Okay. Okay, so what we got here is, is that too washed out? No, that'll be fine. Okay. Um, this is kind of like a logic probe. This is my wire going to it, so this is the probe wire. Okay, so what we have here is kind of like a logic probe, except the idea is to inject a signal rather than measure a signal. So this board is from an old VCR, I'm pretty sure, and it's got a microcontroller that happens to have a pin on it that allows you to connect a ROM externally to it. But you can see that all these pins are all connected to things, and I'm not going to trace every single one of those to find out whether I can tap a ROM into it or not. So what it does is, when you put it in the external ROM mode, then it repurposes these general purpose IOs into regular address and data bus. And so the question is, the data bus is up here, can I tap off of those data lines, hook a ROM up to them, and then have that ROM overpower whatever circuitry is actually there? And then similarly, most of these are the address lines, but since they're outputs, it's a little bit less of a concern. And then we have the crystal down here, and that's driving this thing, but we're talking about maybe we could single step this thing with an external clock source. And I'd like to do all this as non-invasively as possible, so I'd rather not remove circuitry from it, because this is actually just a test run for another system that I definitely don't want to take apart. So what we have here is these resistors correspond with the LED bar that they're above, or that they're near. And let's go back to here. This makes sense. Okay, so this is ignore the bottom part. This is our circuit. We don't know anything about the inputs or the outputs. We don't know whether maybe this is a pull-up resistor or a pull-down resistor. Maybe this is an input. Maybe it's a input that's pulled up internally. Maybe it's not. This could actually be driving this. We don't know. For any of the pins on there, that's kind of where it is. So I've made this probe, and the probe has a resistor here. It drives this signal high or low, and then through this resistor, and it injects that signal into the system, and then it reads it back, and it sees whether it actually gets the high or low that is sending. So for this chip, some of the signals have very tight tolerances, high of 4 volts or higher and a low of 0.6 volts or lower. And so I'm using an analog comparator with voltage references on an AVR. Okay, so what happens is it switches in and out these different resistances, and the bar graph shows what resistance value allows it to overpower the signal without any glitches. So even if the other system is driving somehow, would one of these resistances cause it to be a solid high or a solid low if we drive it with a low or high? So these are the ones that we really pay attention to. These ones, when both of them are on, it means it's sampling. When one of them stays lit, then it means that it's stuck there and none of the resistances could overpower it. So a simple example is, let's do a power signal. Okay, so this is ground, and if we do ground, see right now, like it's just toggling back and forth, and right now it's saying as long as you drive it with 300 kilo ohms, it will drive high or low. That's what it's saying right now. So it can drive low, it can drive high. The two lit at the end say that it's sampling right now. They only light up when it's sampling high, not when it's sampling low. Okay, so if I touch ground, I can't see what I'm doing. Then you gotta wait for a second for it to go through the cycle. But you see the green one doesn't light up at all, and the one before the resistor lights up, so that means it is low already. No resistance changes that. And then the blink over there says that it tried to drive it high, but it couldn't. It's stuck low. And we could do the same thing with high. And this is... okay, there you go. So now we see the same thing. It doesn't take any drive strength to make it high. And when it's done sampling, there we go, it lights up and it says, okay, no drive strength to make it high, but no resistance on the low side could make it low. Okay, so that's what that says. So, an interesting one is the clock signal, which is 1, 2, 3, 4, 5, 6. Is that right? I think that's right. So now what we see is, okay, if we drive it, oh, it's different now. Did I get the right one? I'm shorting 2 pins. Oh, that was stupid. Nope, it's still different. 1, 2, 3, 4, 5, 6. Dagnabbit. 1, 2, 3, 4, 5, 6. It changed. It wasn't that way before. Did I get the wrong number? Okay, well anyways, what we're seeing is we can drive this signal high with 4.4K, and we can drive it low with 270 ohms. That's what this is saying right now. It was 4.4K for both of them. A little more concerning if I have to drive it with 270 ohms. I'll have to think about that. But, so that's the clock signal. So if you look at the clock circuit, then this is how it works. There's the crystal. This is a 1 mega ohm resistor. And the microcontroller has a clock in and a clock out. And so the pin that I was driving was clock in. And so what that means is that I should be able to hook my microcontroller up to it and use it as the clock source. I could tap it right there, and if I have 270 ohms between, then that's enough drive strength to overpower this signal without it toggling outside the high and the low specifications. That's what that means. So, when it was 4.4K, it was a little less concerning. 270 ohms, you know, that means that could be like almost 20 milliamps to overpower that, and that might be a little bit of concern of what we're forcing through this crystal. I've never tried to overpower a crystal before. I don't really know much about crystals, so I can't say whether that's hard on it or not. But anyways, that's what it means. So if we drive that with our microcontroller, 270 ohm resistor can overpower the original clock crystal, and then we can do things with other signals too, like reset and stuff like that. That's where we're headed with this. So, kind of interesting. It's a handy little tool. It's not cat. Hello, kitty cat. What you doing down there? Don't forget me. Okay, hi there, kitty cat. It's in its early stages. We're just got it working. It was supposed to stay lit all the time, not swap back and forth, but actually I kind of like it like this because you can see what's happening. So, and it also means that while it's sampling like that, when it stays at the same resistance for a long time before it gets brighter, that means that it's checking to make sure that no glitches happen at all, that it stays within the voltage specifications. So that is more sophisticated in this debugging attempt than what I originally intended. But alright, that's where we're at so far. Cool.